So number 7 says applying the quadratic formula. Looks like those problems when we had a quadratic equation, one with a squared term, that we tried to solve by factoring because it was set equal to 0. However, try as hard as you can on this one. You probably will not be able to get it to factor because it's going to come out to some really strange answer. So somebody came up with the quadratic formula to solve a quadratic equation. By the way, you can use the quadratic formula to solve the ones that do factor also. Usually factoring is easier to do, and that's why we do factoring first. Quadratic formula says if we have an equation in standard form, ax squared plus bx plus c equals 0, then x is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So I go over here to my quadratic equation. My a value is the coefficient of the x squared term, so it's 5. My b value is the coefficient of my x term, so it's 9. My c value is my constant term, so it's 2. Be careful if there's a negative in front of those, then I include the negative with my number. All of mine are positive on this one. Now I'm going to plug it into my quadratic formula. So I'm thinking about when I plug in for a value, I put it in parentheses. Minus the b value plus or minus the square root of the b value squared minus 4 times the a value times the c value over 2 times the a value. Notice I didn't put my numbers in there yet because I want to point out anywhere I have a variable I'm going to plug in and I'm going to put it in parentheses. So minus the b value is 9, plus or minus the b value squared. The b value again is 9. Minus 4, which is part of my equation, times the a value, which is 5, times the c value, which is 2, over 2 times the a value is 5. So I've plugged all my numbers in. Now I want to simplify this. Since I have minus 9 here, I can drop the parentheses. It's just minus 9 then. Plus or minus the square root of 9 times 9. 9 squared, 81. Minus 4 times 5 times 2. Minus 4 times 5 would be minus 20. Negative 20 times 2 is minus 40. All over 2 times 5, which is 10. I'm then going to do my subtraction underneath my square root. So I have negative 9 plus or minus the square root of 81 minus 40, which is 41, all over 10. Now on the ALEX program, they're going to make you put that in as 2 separate answers. There's not the plus or minus option. So when you put it in, you're going to put in negative 9 plus the square root of 41 over 10. Notice my negative is on top of my fraction. And then you're going to put negative 9 minus the square root of 41 all over 10. What I do is I use your word shortcuts. If you highlight this and hit Control C, that copies. Then if you go over here and hit Control V, it pastes. Then you just need to change the middle sign from a plus to a minus, and you don't have to retype the whole thing. Be careful when you're typing it in. Since this all goes on top, hit the fraction button first, type the top in separately from the bottom, and that works easiest. Otherwise, you have to highlight that to underline the whole thing to make your fraction. But both answers look something like that. I'm going to add some more space here. So number 8, again, it wants us to use the quadratic formula to solve for x. So again, my quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So on this one, a is going to equal 9, b is going to be a negative 5, and c is going to be negative 1. So I'm going to plug those into my quadratic formula. Minus the b value. the b value is negative 5, plus or minus the square root, the b value squared. The b value squared, so negative 5 squared, minus 4 times the a value and times the c value. The a value is 9, the c value is negative 1. All over 2 times the a value is 9. So plugged in my numbers for a, b, and c. Now I need to simplify. On this one, we have minus a negative 5. Minus a negative 5 would make that positive 5. Plus or minus the square root of a negative 5 squared. Negative 5 times negative 5 should be positive 25. If you put this in your calculator without the parentheses, you're going to get the wrong sign, so be sure you use the parentheses if you have to use your calculator. Negative 4 times 9 would be negative 36. A negative 36 times a negative 1 going to be positive 36 then. Over 2 times 9, 18. So on this one here, we're going to add. We're going to get 5 plus or minus the square root of 25 plus 36, which would be 61, all over 18. So again, you're going to have your two different answers. X is going to be 5 plus the square root of 61 over 18, and 5 minus the square root of 61 over 18. Make sure that fraction bar goes under everything on the numerator, not just under the 61. It goes all the way across. So not so bad once you get the numbers in and you know where everything goes. Let's try one more of those. Number 9. Number 9, again, we want to use our quadratic formula. I like to write big, so I'm going to add a little more space to our paper. You don't have that option, but maybe by the time I print them out next time, there'll be plenty of room. So my quadratic formula again. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So a in this case is going to be 3, b is also going to be 3, and c is going to be negative 7. So plugging those into my quadratic formula, I'm going to have minus the b value. The b value is 3, plus or minus the square root of the b value squared. The b value is 3 again, minus 4 times the a value times the c value. A is 3, c is negative 7. All over 2 times the a value is 3. So simplifying, here we get minus 3 plus or minus the square root. 3 squared, 3 times 3 is 9. Negative 4 times 3 would be negative 12. A negative 12 times a negative 7. Negative times a negative is a positive. 12 times 7. 84. Over 2 times 3, 6. So again here, since we had a negative times a negative, we had a positive, we're going to add. So we get negative 3 plus or minus the square root of 84 plus 9 would be 93 over 2 times 3, which we already did, was 6. And so we get our two answers. X is going to equal negative 3 plus the square root of 93 over 6, and negative 3 minus the square root of 93 over 6. And both of those two things have to go in for my answer. Now there are some equations where once you have your square root, you can simplify your square root. Right now in intermediate algebra, they don't make you simplify it. It'll say it's correct. However, you could have simplified it into this. So if you want to practice doing that, you can. Once we get into college algebra, we'll worry more about trying to simplify our radicals. But in this case, if you can get it this far, we're going to call that good enough.